Okay, stick around. We're going to be moving on with our next speaker now. I was just chatting to him, Matt Miesnieks. He's from 6D.ai, also one of the partners at SuperVentures as well. So a big round of applause for Matt.
All right, thanks, Nick. Yeah, I'm Matt from 6D. We are a company that's a spin-out from Oxford University that really builds really deep tech computer vision to solve some really hard computer vision problems for AR developers and creators. But what I wanted to talk about today is less about 6D and the how things work and the what things are, but more about the why. Why I started this company, why we're trying to solve an important problem, and really what it's going to mean to everybody working in the AR and eventually VR space. Alex Chung talked earlier about the AR cloud and gave a great overview of what it was. And I want to talk a little bit about why the AR cloud matters. The thing that fascinates me about AR is that it's natively as a medium, it's a deeply immersive and sensory experience. It engages us in a way that no other medium can. And the sad fact of it is that today, all of our AR experiences are pretty much islands. If you use an AR Core app or a HoloLens experience, you're there on your own, you're experiencing it on your own, and you can barely get a sense of what it's like to connect all of those senses in the way that the medium has the potential to another person. So that problem, I've been working on it now for 10 years almost. The 6D is my third company, third attempt to solve this. And it's been a really challenging problem to solve. How do you build the infrastructure that connects apps to each other? And by connecting those AR experiences to each other, how do we then connect ourselves to each other and to the world in ways that have been impossible to now? So as Ori and I and Tom were talking about the problem here and what has to happen, how do these experiences persist when devices aren't there? How do you have a model of the world that's bigger than can fit on a phone or on a headset? We realized that a lot of the enabling pieces for these experiences needed to live in the cloud. And so that's where the term AR cloud came from. It was what parts of the AR enablers live outside the device, somewhere out there in the cloud. And that has turned out to be a big idea. It goes a long way in terms of enabling what AR can be and what its potential can be. So the bridges, if each of these islands here is a little AR app, what are the bridges and what do they look like? How does this, what does it mean really? How's it different from the regular cloud? And at its heart, if you look at the way an AR system works, you may have heard terms like point clouds or SLAM, those maps, those sorts of things. But in this image, each of these, each of those three images is a different AR system with its own SLAM map or SLAM point cloud, of the world that it's looking at. And it's been impossible until recently to even really share those maps between devices. And it's that ability to share them and aggregate them, combine them, and then derive some meaning from them that is what the AR cloud enables. And I'm talking AR cloud in the singular, but really it's a whole universe of different services, and it's not necessarily one company that's going to own them all, but in aggregate, we're referring it to the AR cloud. So if you can solve this problem of sort of merging these computer vision systems together and getting all the headsets to talk to phones and iOS to talk to Android and all that sort of stuff, what starts to become possible? And we've seen with iOS 12 and Google's AR Cloud Anchors and stuff that we've done at 6D, you now start to have multiplayer and persistent content. These have been features that have really blocked AR from being feeling real, I guess. The content needs for the content to feel like it's part of the world and for people to suspend disbelief. If you put something digital in a place, you want it to stay there. And if someone else comes along, you want them to be able to also see it. And the interesting thing about this is that because a lot of the early developers in AR have had to have knowledge of 3D, 3D content and building 3D experiences, a lot of them have come from the gaming world. And so terms like multiplayer have kind of stuck for this type of experience. But when you think about this new medium, if you only look at it through the lens of like a gaming or an entertainment product, then you're probably missing about 90% of the potential. If you swap out the word multiplayer and start using words like sharing or social or communicating, that's what this starts to enable. Like, how do we communicate in this new medium? How do we share experiences with each other, that someone who may be with us or maybe remotely? And so that ability for multiplayer to be a seamless, persistent experience is fundamental for AR and VR to get outside of a sort of a game console-sized market and eventually reach out into a smartphone-sized market. Now, anyone who's played with a AR Core or AR Kit app has probably had the experience of dropping an asset and then walking around the corner and you can still see the asset where it should be hidden behind a wall. That's called occlusion, or physics, where the content should physically interact with the world. And my friend Charlie, who's about to speak next, talks about painting the world with data. And what that starts to look like is, in this case, it's a Minecraft-style game that Microsoft showed off. You've got content on all different surfaces. It's physically interacting, and it's effectively you're taking digital content and smearing it all over the world. And that's a really cool experience, a cool user experience. But the trick with doing this is that before you can paint the world with data, you need actually a digital model of the world to paint on. And in this case, it's just showing like a mesh of a couch. And up to now, getting that model has always been a chicken and egg for any application developer. Because to build a 3D model of this room or of your home, you've either needed to take 1,000 photos and upload them to a server and do some sort of photogrammetry with a whole bunch of manual cleanup, or you've needed to use hardware that has an active depth camera, and you're restricted to things like Google's Tango phones or HoloLens and Magic Leap, and it was never a mass market solution. And so whatever it was going to be expensive to capture that content, no one was going to do it at a large scale unless there was an application to take advantage of it. And no one was going to build the application that took advantage of the 3D world unless that model was there. So that chicken and egg has always existed. And I guess the reason I started 6D was I met my co-founder and Professor Victor Prisakaru from Oxford University, and his computer vision lab had really figured out a way to build a model of the world in real time in the background on a regular mass market phone. So you didn't need any special hardware anymore. And so application developers could just assume that that model was there, and if the model wasn't already there, we could build it as the app built out. And so in this case, from one of our little demo apps, as you just wave your phone around, it captures a model of the coffee table and of the basket, and you can throw some digital balls and they bounce around appropriately and get captured in that, in the basket. So that's all kind of cool. But then the first question when we show this off, after people get over it, they say, well, what happens when someone walks in front of you? And so Niantic showed a demo or a concept video about a month ago of Pikachu like running between people's legs. And so the AR cloud starts to go to that next stage of having some intelligence about your scene and occlusion. And this is where Google's investing a lot in their Lens product. We're also investing in this space. And you start to be able to track moving objects in a scene and identify what they are. And so your applications start to become very aware of the real world. And they can start to, as an application developer, you can start to put logic into your apps to respond appropriately. If there's a tree in the scene, your Pokemon might know to go and hide in the tree. If there's something giving you navigation around the street corner, the line will be occluded as it goes around the corner, or occluded if a car goes in front of it. So these are all the sorts of enablers that are going to change the way that change the type of apps that we're able to build. And we get from, like this example shows, AR apps that work on like a tabletop or on a corner of a room to really world-scale apps. And the challenge in doing this is to build out the AR cloud features. Like Alex mentioned, you need to build literally a one-to-one scale model of the real world that is almost updated in real time as things change. So it's a huge problem and a huge opportunity. But it's not enough. This is one thing I learned from trying to solve this problem several times before. It's that putting aside like the application itself, your menu items, the quality of your graphics, the user flow through your app, but the computer vision itself is a user experience. And just because something works doesn't mean it's good enough, as the plug shows. And we've seen how, in over 10 years, we've had AR that worked. And if you're willing to ask a consumer to print out a piece of paper and put it on the ground with a marker on it, you could get a good AR experience. If you're willing to build by hand, a model of a solid object and sort of manually line it up, you could get occlusion and stuff working. But getting from that works to something that just works, which AR Core and AR Kit achieved a year ago, that's when the game changed for AR in particular. Anyone could just open their phone and turn their phone on and just have a piece of content appear. And so that's now like today's challenge for multiplayer and persistence and occlusion. How do you get it to be something that just works for everybody? But even that isn't enough, because you've built now this amazing data set, you've made it really easy to use for everyone. But what people start to realize is that, hang on, if I'm playing Pokemon in my kitchen, has Niantic just sucked up a model of my kitchen and they're holding it on their servers, and what the hell are they going to do with that? And so privacy, even more than your search history, it matters. It's even more sensitive. So the responsibility, I think, for companies like ours, as well as the Facebooks and Googles of the world, is to be very visible, very proactive, and really start to engage with people as to what do you expect, because there's a lot of pre-existing norms that we're happy with. If you come to my house and I invite you for dinner and you're in my lounge room and you pull your phone out, I don't immediately freak out thinking that you're about to record a video of my home, but even if you did take a photo, I'm probably going to be okay with that. But if you're wearing Magic Leap glasses and you just happen to wander down the hallway and happen to glance into my kid's bedroom, has Magic Leap now got an image of my kid's bedroom on their servers? And so the trick is only partly technical. A big part of the solving this problem is going to be around helping people understand and have sort of informed consent as to how this data is being used and how it's not going to be used down the track. And as an example, today we could capture this type of mesh with photorealistic content and save it in our servers, but we've chosen not to. And instead, a similar scene, it looks like this. It's something that, from our point of view, we can't actually take this data and turn it back into an image that someone can, any human could read. So that sort of one-way translation is, I guess, one step we're taking, but there's going to be far, far more problems down the road. And I think that the attention that's being placed on privacy, over the recent Facebook scandals and things is something that we're going to have to care much, much more about as we get into AR and some of these cloud-enabled services. Because one of my favorite slides, there is no cloud. At the end of the day, it's just someone else's computer that data sits on. So how do you make sure that other person is acting responsibly and treating your data with respect? So everything I described, even if we solve these problems, like we solve the technology, we solve the privacy, we make it really easy to use, it's still not enough, because this is really the beginning of a platform shift in the sense of going from PC to mobile, or mobile to whatever, AR, spatial, whatever name it ends up being called. But this transition from building apps that live on flat screens to building apps that have some awareness of the real world is going to be sort of the next decade, I think, of opportunity. And what that's going to result in is effectively a new type of operating system or operating platform. Historically, an operating system has meant a bunch of APIs that developers can call to access the hardware of the device and drive the UI. And then about 15 years ago or so, the APIs for shared services started to become essential for every app that you built. And Amazon Web Services, they give it this name, Web Services, but from an applications point of view, it's almost an operating system for the cloud. It's I save files, I retrieve files, I pass things around. And in the same way, we're going to need another set of APIs to understand the real world. And that, from the applications point of view, is going to look like an operating system in itself. And it's far more than just, here's the mesh or the geometry of the real world, or here's the coordinates of everybody so we can do multiplayer. The advances in neural networks and deep learning mean we're going to have, beyond just identifying things like knowing that's a chair or your name, it's going to start recognizing gestures, start recognizing emotions, and then even start to be predictive in what's going to happen. In that if your system sees a ball bouncing along the sidewalk, your autonomous vehicle might know to preemptively slow down because often children are running behind a ball that bounces on the road, and they can start to predict what happens. So this real-world operating system is really going to be that platform that we believe is going to be ultimately the most valuable asset of the next platform transition. Similar to, like Alex said, similar to Google's search index or Facebook's social graph, and it's a hugely important topic that's eventually going to affect all of our lives. So in finishing up, AR cloud, when you hear that term, it's not like a one thing. It's not just a one sort of someone building a big model of everything, but it's really a set of APIs, a set of capabilities that are going to change what AR apps are capable of. But the reason for that, the reason that we do it all, is going back to right at the beginning, is to really unlock that potential of AR to literally change how we see the world and start to connect ourselves in ways that we can't currently do to people, to places, and to things in our lives. So thank you.